Alright, now we're on to day 5 of Unit 3, Polynomials, and today we're going to work with operations of polynomials. So we're going to take a look at example 6 and example 7. So this first one just asks you to find the perimeter of the polygon below. So remember, perimeter is when you just take the sum of the sides. So all you have to do is add these numbers together. So I'm just going to write them all together. I've got 3x to the third plus 3x squared, 3x to the third plus 2x minus 6 plus x to the fourth plus 2x to the third squared plus 2x minus 4. So looking at the highest exponent, I have x to the fourth, and there's no one to add it with, so it's just x to the fourth. Then I look at my x to the thirds, I get 2 of them, so that's 6x to the third. Looking at my x squared, there's only 1, so it's all by itself, 2x squared. I have 2x plus 2x, which is 4x. And negative 6 minus 4 is negative 10. So there's the perimeter of that triangle, combining like terms with polynomials. Part B is similar. It says determine the missing side and length given the triangle and its perimeter below. So this time they're giving us the perimeter, and they're trying to get us to find this side. So remember back in geometry, in a trapezoid, if these two sides are congruent if they have those tick marks. This is also 4x to the third. So looking for that, I have to take this value and subtract the other values that I have to find this missing side. So I'm going to write the first one in parentheses, 2x to the fourth minus 6x to the third plus 2x minus, and let's see, x to the fourth is all by itself. There's no x, there are x to the third terms, that's 2 of them, so it's 4 plus 4 is 8x to the third. No x squareds, and then plus 2x. So we're subtracting, so I'm taking 2x to the fourth minus x to the fourth, so that gives me 1x to the fourth. Negative 6x to the third minus 8x to the third is negative 14x to the third. And 2x minus 2x is 0. So that's the length of the missing side. That would go right there. So there you can see our answer. 2x to the fourth minus x to the fourth is x to the fourth. Negative 6x to the third minus 8x to the third is negative 14x to the third. And 2x minus 2x is 0, so we're left with that answer. Alright, the last one, determine the volume. Remember volume, it gives you the formula as length times width times height. So I'm just going to multiply the three values together. When you're multiplying binomials, you are going to have to multiply the first two binomials together and find your answer, and then multiply that by the third one. So I'm going to multiply 2x times x and get 2x squared. 2x times 1 and get 2x. 2 times x, which is 2x. And 2 times 1, which is 2. All times x plus 3. Combine like terms and make it a little bit easier. Two x squared times x is 2x to the third. 2x squared times 3 is 6x squared. 4x times x is 4x squared. 4x times 3 is 12x. 2 times x is 2x. And 2 times 3 is 6. So I had to take each term and multiply it by the other two terms in the binomial. And now you combine like terms. 6 plus 4 is 10, so that's 10x squared. 12 plus 2 is 14, so that's 14x plus 6. Alright, and let's try the last two, example 7. So it's asking you to write the following expression in two equivalent forms. So we're going to do the same thing here, where we multiply the first two binomials together, get our answer, then multiply by the third binomial. And actually doing that process will give us two of the equivalent forms. So I've got 3x squared minus 6x plus 6x minus 12 times 2x minus 1. So technically right here, this is one equivalent expression for the one above. Simplifying it, 3x squared minus 12 times 2x minus 1, because negative 6 plus 6 is 0. Here is another equivalent expression. And then if we did it again, I can get to another one. It'd be 6x to the third minus 3x squared minus 24x plus 24. So now I've got a third equivalent expression, because as I'm working through this, these are all equivalent to the one that we started with. And then simplifying it, we have 6x to the third. Oh, actually, that's our last answer. There are no like terms here. So here are three different equivalent expressions that go with that first one as well. For part B, same idea. I'm going to write this without the exponent. So here's an equivalent form. I just expanded it. And then to get another one, I could multiply. And there's another equivalent expression. And then combining like terms gives me a third way to write this expression that's given to you. That's what it means when it says equivalent. Things that are the same, but written different ways.